Good morning. This morning we are starting with organic reactions, substitution. So the previous 2 days we did addition reactions. Now we are doing elimination, and we did elimination reactions. Today we are doing substitution reactions. Planning for today, a memo of elimination reactions was sent to you this morning. The substitution reactions in the textbook, each from page 116 to 118. Homework is exercise 12 of the substitution questions 1 to 8. So what is a substitution reaction? That's what the word says. It's going to substitute something. So a substitution reaction is a chemical reaction in which an atom or a group of atoms in a molecule are displaced or substituted by another atom or group of atoms. So if you look at the general equation here, we start with A, B, and C, D. So what's going to happen is D and B is going to substitute. So our product will then be AD, and then our new product that will form will be BC. So there is a substitution of an atom or a group of atoms with each other. So if we look at this in general, so here we have a ethane structure, a 2-carbon structure. So if we take the compound B and we substitute it, with compound Y, we will see that Y and B changed positions, and we get our new substance BC. So our first type of substitution reaction we get is halogenation. In other words, we are adding a halogen to it. The halogens we normally use is most hydrogen, bromine, iodine, chlorine, and fluorine. So what will we get? We will get an alkane that will be converted to a haloalkane. The reaction condition is there must be heat or sunlight. So the alkane will react with the halogen. We will form a haloalkane and a hydrogen halide. So that's what we will form. So a substitution reaction occurs where the hydrogen atom in the alkane is displaced one at a time by the halogen atom to form a haloalkane and a hydrogen halide as a product. So like I said, what is the reaction conditions? Again, remember, reaction conditions is very important. We use heat or sunlight, and it's extremely slow, this reaction. So the reactants is alkanes and halogens, which forms haloalkanes and a halogen halide. Let's look at an example. So we have ethane that bonds with the with a halogen. So the hydrogen and the bromine are going to swap places in sunlight, and then we will find our new compounds, and there you can see the two swapped places. So now we have bromoethane, or 1-bromoethane, and we have halogen bromide and not bromine. Okay, our second one, substitution reaction, where we find halogenation still, is where we convert a alcohol to a haloalkane. So the alcohol will then bond with a hydrogen halide to form a haloalkane and water. The reaction conditions for tertiary alcohols. Remember, what is tertiary again? We have our carbon, and it's bonded to our OH. Tertiary means it's bonded to 3 other carbon compounds. And then primary and secondary again. Primary the OH, the carbon is bonded the carbon of the OH for a primary is bonded to one more carbon. So this is primary, and then secondary is when it's bonded to two carbons. Okay, so for the tertiary alcohol, which we have there, the HBr or the HCl added is directly at room temperature. For the primary or the secondary alcohol, we add solid NHBr or potassium bromide plus sulfuric acid, and it's used to make HBr in a reaction flask, and the HBr reacts slowly with the alcohol, so this must also be heated. So the reaction is then alcohol plus hydrogen halide, which will form a haloalkane and water. So let's look at the primary one. Okay, so here is a general one. It's the OH, and the X will then change places in the presence of heat. Here's another one, propane 1-ol. This is a primary because it's only bonded to one other carbon. The OH and the Br changes positions. We get 1-chloropropane and water. For the secondary, now the carbon is on, the OH is on the carbon 2, bonded to 2 other carbons. So the OH and the Cl changes position, and we get 2-chloropropane and water, also still heated. In the tertiary one, the OH and the HBr is going to swap places again. This one happens at room temperature, the other two happens when we heat up our substance. So if you look at the three differences, here we just had heat, here we just had heat, and here it is done at room temperature. So if we go back, so this is happening at room temperature. For primaries and secondaries, we use a solid NHBr and also sulfuric acid so that we can get this reaction going. Our last substitution reaction is hydrolysis. In other words, where we are creating a compound where we make a alcohol. So there's two methods. Methods 1, the haloalkane can be converted to an alcohol in a substitution reaction by the use of an aqueous solution of a strong base such as NaOH, KOH and LOH. The NaOH, the KOH and the LOH will have an OH substitute, and it converts the haloalkane to the alcohol. Very important, this is a diluted strong base, so in other words, it's in an aqueous solution. You dissolve the haloalkane in ethanol and you heat the mixture moderately. This is also very important. We heat it moderately, and we should know that there is a correlation between this first method of hydrolysis and the elimination method. And I just want to show you this, because here is the elimination reaction where we use dehydrogenation. In the previous one, we did hydrolysis. So now in elimination, we use dehydrogenation. We still dissolve the base in ethanol, but here we use a concentrated solution. With the previous one, we use a diluted one, and in the dehydrogenation, we use a strong heat. So what is the difference? If we go back again, diluted strong base, moderately heated, and then the reactants will be a haloalkane, and the diluted strong base will form an alcohol, salt, and where our first method also formed water, in this case you will see there's no water formed. So if we use a diluted strong base and we use substitution, we do not form water. Method 2, the haloalkanes can be converted through substitution by making use of excess water. So now we just have to add water to make a alcohol, and a hydrogen halide. So it's excess water. We dissolve the haloalkane in ethanol, like in our previous one, and we also heat it moderately. So everything is more or less the same, but method 1, we use a diluted strong base. Here we use excess water. So the reactants will be haloalkane and water, and alcohol and hydrogen halide. Alright, so let's look at a few examples again. Example 1, method 1, we use a diluted base, NaOH, KOH, lithium hydroxide. The chlorine and the OH changes position, and we get a propanol and a salt, which is sodium chloride. Method 2, instead of using a base, we use water, and the OH will bond with the Cl, and we will get our alcohol and our HCl. We look at example number 2, adding a KOH. Again, this is diluted. You can see we swap the OH and the Br. We get our halogen bromide, and we get our alcohol. We use method 2. We use water instead of our base, and then we have Br and water. The OH and the Br will substitute to form our 2-methylpropanol and our hydrogen bromide. Homework for today is substitution exercise 12, question 1 to question 8. For the elimination reactions, the group will be open for discussion from 2 to 5 today, so please submit your requests. Thank you. Have a good day. Bye.